CS stage with current source load. In applications requiring a large voltage gain in a single stage, the relationship AV is equals to minus GM RD suggests that we increase the load impedance of the CS stage with a resistor or diode connected load. However, increasing the load resistance limits the output voltage swing. A more practical approach is to replace the load with a current source described briefly in an example. The resulting circuit is shown in figure where both transistors operate in saturation, since the total impedance seen at the output node is equal to R01 parallel to R02. The gain is here. You can see the figure. CS stage with current source load, AV equal to minus GM1 R01 parallel to R02. The key point here is that the output impedance and the minimum required mod VDS of M2 are less strongly coupled than the value and the voltage drop of a resistor, and then the voltage drop of a resistor, the voltage mod VDS to min is equals to VGS2 minus VTH2 can be reduced to even a few hundred millivolts by simply increasing the width of M2. If R02 is not sufficiently high, the length and width of M2 can be increased to achieve a smaller lambda while maintaining the same overdrive voltage. The penalty is the large capacitance introduced by M2 at the output node. We should remark that the output bias voltage of the circuit in figure is not well defined. Thus, the stage is reliably based only if feedback loop forces V out to a known value. The large signal analysis of the circuit is left as an exercise for the reader. As explained in chapter, the output impedance of MOSFET at a given drain current can be scaled by changing the channel length, that is to the first order lambda inversely proportional to 1 by L, and hence R0 is inversely proportional to L by RD. Since the gain of the stage is shown in figure is proportional to R01 parallel to R02, we may summarize that longer transistors yield a higher voltage gain. Let us consider M1 M2 separately. If L1 is scaled by a factor lambda, if L1 is scaled by a factor alpha greater than 1, then W may need to be scaled proportionally as well. This is because for a given drain current VGS1 minus VTH1 inversely proportional to 1 by root over W by L1, that is, if W1 is not scaled, the override voltage increases, limiting the output voltage swing. Also, since GM1 directly proportional to root over W by L1, scaling up only L1 lowers GM1. In applications where these issues are unimportant, W1 can remain constant where L1 increases. Thus, the intrinsic gain of the transistor can be written as GM1 R01 equal to root over 2 W by L1 nu and C0 tax ID 1 by lambda ID, indicating that the gain increases with L because lambda depends more strongly on L than GM does. Also note that GM are not decreases as RD increases. Increasing L2 while keeping W2 constant increases are not to enhance the voltage gain but at the cost of higher mod VDS2 required to maintain M2 in saturation. Thank you.